Hey guys, how you doing? It's Coach Scott, and well, let's go ahead and we've seen the video or we've done our experiment. Let's look at some of the numbers that I've got. Okay, so again, here's our sheet. Now I was on balance three, so I'm gonna write that down real quick. And if you recall from the video, the mass of my beaker was 68.057. The mass of my vial was 7.9991 and silver nitrate. Okay, and the mass of my copper wire was 1.838 grams. Now the mass of the empty vial was 5.461. Okay, the mass of my copper wire after, and now if you think about it, that should be less than here, and it is. It's 1.358 grams. The mass of the beaker in the dry silver, when I took it out of the drying oven, well, it's 69.614. Okay, so that is more than what it was when it was initially weighed. So it did gain mass, and that makes sense. So our first problem, what we need to do, is determine the mass of the copper that was reacted. So if I subtract my copper wire from when I started till after it was in, okay, I've got that's the mass of copper used. All right, if I subtract or 1.358 from 1.838, okay, what I get is 0.480 grams of copper. Okay, that makes sense. So I lost copper. Now let's see what the mass of silver I produced. All right, so if I subtract the mass of the beaker and the dry silver and the mass of the beaker with the empty beaker before anything started, I got 1.557 grams of silver. Okay, that gives me the mass of what I reacted and what I consumed, and that's cool, but I need moles. And if you recall from my previous video, if you grab your periodic table, let's go ahead and convert this into moles. So if I have 0.48 grams of copper and I need to know the number of moles, I've got to multiply that by the mole ratio. So the mole ratio I get from my periodic table, so that could be either 1 mole over 63.546 grams or 63.546 grams over 1 mole. Well, I want moles, so I'm going to put it on top. So I'm going to write that down there, 63.546. And I hit my calculator. All right, let's do that real quick. So I got 0.480 divided by 63.546. That gave me 0.00755 moles of copper that were used. 0.00755. And I could put some more digits, but 3 digits are significant, and that's all I'm going to worry about. Okay, so we're good there. So let's determine what the mass of the silver is. Okay, so if I look at my periodic table, I see that silver has a molar mass of 107.8682 grams for 1 mole. Or it's 1 mole for 107 point whatever it is, 8682. So let's write that down. So of course what I want to do is multiply that by something. I'm going to put my mole on top. Look at my periodic table. 107.8682 grams. All right, let's see what that is. So 1.557 divided by 107.8682. I got, oh, cool. So how many moles? I got 0.0144 4 moles of silver, Ag. We're going to put moles of copper. Okay, so let's see what the value of the ratio. All right, our moles of silver to our moles of copper. And remember when we first started, we didn't know if this is copper 1 or copper 2. So let's see. If we recall, we did the 2 types of reactions. So if it's copper 1, it ought to be a 1-to-1 relationship. Well, let's look. So my moles of silver, 0.0144 moles silver. I'm going to divide it. I'll get the ratio. 0.0755 moles copper. Let's see what we get. All right, divided by 0.00755. What do we get? Ooh, I got 1.91. 0.91. That's my ratio. That's almost 2 to 1. So let's determine the mass of the and the number of moles of silver nitrate. So if we look at our, if we subtract the total mass of silver nitrate we used, okay. All right, we started with 2.53, I believe, grams. All right, let's write that down. 2.530. So much we started with. So let's do our molar mass of that. So I take silver plus nitrogen plus 3 oxygens. Okay, so I already worked that math out. So it's 169. Of course, that's grams. 1 mole is 169 of silver nitrate, 0.874 grams. Do my math. Okay. So if I take 2.53, and divide by 169.874, ooh, let's see what I got here. There I've got 0.0149 moles of silver nitrate. I might be seeing a pattern here. So let's look at what this this molar ratio is. So my moles of silver, 0.0144 moles Ag. And let's get that ratio, 0.0149 moles of AgNO3. See what that ratio is. 0.144 divided by 0.1049. I got 0.966 or 9.97. All right. 0.97. That's almost a 1-to-1 relationship. And that's almost a 2-to-1 relationship. Let's see if this makes sense. So what do you think the actual ratio of moles of silver to moles of copper consumed? Well, what do you think? We're going to do the averages of that, and we'll come up with that. But it's almost like a 2-to-1 ratio. But so anyway, those are the numbers we're going to need. We're going to put these in a table in class, and it'll be pretty cool. We'll do our BCA table off that, and then we'll see what we got. And it looks like my numbers were pretty good. So anyway, this should be a pretty cool lab. Hopefully we'll learn something from it. This is Coach Scott saying, Hullabaloo, Connect.